problem number 25 from homework 2.5 day 2. Here we're asked to describe the transformation from the common function and then sketch the graph of f of x equals x minus 1 cubed plus 2. We're going to look at this equation and try to identify the parent function. The parent function is y equals x cubed. That's our parent function. That's our disco function. And then we're going to identify the various transformations that we see in the equation. The first thing I'm going to take note of is this minus 1 inside the function. We're replacing x with x minus 1. That's a transformation which is going to shift the graph right 1. So replacing x with x minus 1 shifts the graph right 1. And then the other transformation that I see is that I have a plus 2 outside the function, outside the x cubed part. The plus 2 is the transformation moving the graph up 2. So then the next thing that we want to do is we're going to figure out how we will transform points from the parent function to the new function, the transform function. And I'm going to think about what I need to do to x values and what I need to do to y values. A shift of graph right 1 means I'm going to add 1 to all the x values on the parent function, and a shift up 2 means I'm going to add 2 to all the y values. Now we need to get some points on our parent function. We'll transform them and get points on our new function. So the points on the parent function of x cubed, I'm going to choose negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. To each of those points on the parent function, I'm going to add 1 to all the x values to get the new x values and 2 to all the y values. So I'm just going to do the x values first. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. I have my new x coordinates. The thing that I'm going to do is I'm going to add 2 to all the y values. So negative 8 plus 2 is negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 8 plus 2 is 10. Those will be the new points on my transform function. And now we can go ahead and plot those points. So negative 1, negative 6, 1, 2, 3, 4, 5, 6. 0, 1, 1, 2, 2, 3, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my function f of x. And I can connect those with a smooth curve. And we should think about, is this something that we'd expect? I'm going to sketch in the parent function. That was at 0, 0, 1, 1, negative 1, negative 1, 2, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is y equals x cubed, which is the parent function, and negative 2, negative 8, which is right there. I'm going to sketch this in with a dashed line. So the other way you could also solve this problem is you can first graph the parent function, and then you could take each point on the parent function and move them right 1 up 2. So for example, 0, 0 would become 1, 2, the point 1, 1, move right 1 up 2. So two different ways to think about the graphs of the transformation, either doing it analytically with the table or just graphically by moving points from the parent function to the transform function.